Okay, n is just a distribution problem. So I'm going to multiply this times each thing in here, so this becomes 2 root x times root 5x minus 2 root x times 9. So this becomes 2 times the square root of x times 5 times x minus 2 times 9 times the square root of x. Okay, well I have two x's here, so I can pull that out, so this becomes 2x times the square root of 5 minus 18 times the square root of x. These are not like, so I can't do anything with them. Alright, if you'll notice this 3x squared, the square root of 3x squared minus 8 times the square root of 3x squared plus 8, this is a difference of squares. So if I recognize the pattern, this is just the square root of 3x to the second squared minus 8 squared, which gives me 3x squared minus 64. Okay. Alright, if I don't see that, just distribute. So that's the square root of 3x squared times the square root of 3x squared minus 8 times the square root of 3x squared. I'm sorry, that's a plus. Minus 8 times the square root of 3x squared minus 64. Well, the square root of anything times itself is just the radicand. These are the same and cancel out, and I get minus 64. Okay, so let's rationalize the denominator now. Go on to problem number 9. Okay. Rationalize the denominator. What that means is eliminate the radicals in the denominator. Okay, so if I have 3 over the square root of 2x, I need to get rid of that denominator. So I need pairs under here. I need a pair of 2's and I need a pair of x's. So if I multiply that by the square root of 2x, then that will give me this becomes then the square root of 2 squared times x squared, and that'll get rid of it. But if I'm going to do that to the denominator, I have to do that to the numerator as well. So this becomes 3 times the square root of 2x over the square root of 2 squared times x squared, which is just 3 times the square root of 2x divided by 2 times x. And there's no radical left in there. Okay, so now if I have the fourth root down here, I am going to have to figure out what to multiply this by in order to get factors, 4 of identical factors. All right, well I'm going to start out by writing this. Let's do it down here. So this is the fourth root, and let's see, 27 is divisible by 3, divisible by 3. So that is 3 times 3 times 3, and x times x times x. Okay. So I'm going to have to, the index has to be the same. I have 3 3's, but since it's the fourth root, I need another one. I have 3 x's. In order to do the fourth root, I need another one. So I'm going to have to multiply the numerator also by the fourth root of 3x. So this becomes 2x times the 4th root of 3x divided by the 4th root, 3 times 3 times 3, so I've got 3 to the 4th and x to the 4th. So that becomes 2x times the 4th root of 3x divided by 3x. Okay, well, the 2 and the 3 I can't do anything to, but anything divided by itself becomes 1. So this becomes 2 times the 4th root of 3x divided by 3. Okay. All right, for C, let me brighten this up just a little bit. I have the cube root of 25m to the second. Okay. So this is actually 9 divided by the cube root of 5 times 5 times m. I need groups of 3, so I'm going to have to multiply it by the cube root of something. I have 2 m's, excuse me, 2 5's, I need another. I have 1 m, I need 2 more. If I did it to the denominator, I have to do it to the numerator. So this becomes 9 times the cube root of 5m to the second divided by the cube root of 5 to the third times m to the third, which is 9 times the cube root of 5m to the second divided by 5m. There's nothing outside the radical that can be factored, so you're done. Okay, if your denominator has a sum or a difference in it, you're going to have to multiply by the conjugate. So remember, the conjugates are a plus b and a minus b. So if you have a minus b, then what you want to do is multiply it by its conjugate, which is 5 plus the square root of 3. Since you did it to the denominator, you have to do it to the numerator. So I'm going to distribute here. This becomes 5 times the square root of 3 plus the square root of 3 times the square root of 3 divided by, and this is where it's important to know this difference of squares pattern. This becomes 5 squared minus the square root of 3 squared. So this becomes 5 root 3 plus 9 divided by 25 minus 3, which is 5 root 3 plus 9 divided by 22. Nothing can be simplified. Same thing, I have a sum here, so I'm going to have to multiply by its conjugate, which becomes root 6 minus root 5. And I have to do that to my denominator as well. Okay, so if I distribute here, this becomes 11 root 6 minus 11 root 5 divided by root 6 squared minus root 5 squared. Nothing I can do up here, This is just 11 root 6 minus 11 root 5. Root 6 squared is 6. Root 5 squared is 5. That becomes 1. So this just becomes 11 root 6 minus 11 root 5. Okay, same thing here. Root 13 plus 2. Can't have that radical in the denominator, so I'm going to have to multiply by its conjugate, which is root 13 minus 2. Okay. All right, so when I do that, this is going to take me a little bit. Okay, so this gives me 3 root 13 minus 6 minus root 13 squared minus 2 root 13, all divided by root 13 squared minus 2 squared. Okay, so let's see what that gives me. That gives me 3 root 13 minus 6 minus 13 minus 2 root 13 divided by 13 minus 4. Oops, and that's a plus. So 3 root 13 plus 2 root 13 gives me 5 root 13. Negative 6 minus 13 is minus 19. 13 minus 4 is 9. That cannot be simplified, so there's your answer. Okay, I'll switch again before we go to